Hi everybody, I'm going to take us through a handwritten example of how to do an activity on node network diagram. Please check out, located in module number 3, the classroom example, which is essentially an example that I used from a project that I worked on at Rochester General implementing an electronic medical record. I took a pretty basic snapshot at some of the major activity components, the expected, the most likely times, as well as the optimistic and pessimistic times, and basically put together this example to take you through how you would do a traditional kind of critical path method approach to project management as well as PERT. And again, there's another term for this which isn't mentioned in the book, but this would be kind of waterfall project management. There's a new field of study called agile project management, especially with software projects. That's very useful, but again, this is going to be just traditional waterfall project management, going through sequential activities and understanding the critical path. So with that, I'm going to walk you through how to do an AON network. So first and foremost, we want to use all of our activities here and make sure that they have all the predecessor relationships. And the way this works is that so activity B, workflow review, cannot start until A is complete, so the build team training, right? So they can't get started working on understanding the workflows in the organization until they've had their training, and so on and so forth. So using these predecessor relationships, our first step in doing the AON network diagram is to go ahead and map these relationships. So this is going to look like we're, in this case, going to start with activity A. And I always just do a cross right in the middle of it because here we're going to have our early start, early finish, late start, and late finish activity times. So this is activity A, and I also like to put in here what the most likely activity time is. In this case, it's 4 months. 4. So now we'll go to activity B. Activity B cannot start until A is complete. So we can put B up here, and the most likely time for activity B is 3 months, so A goes to B. Activity C cannot start until A is complete, so we'll have activity C down here, and that takes 6 months. That goes there. Now we have activity D, system build, cannot start until both B and C are complete. So in this case we'll have D, which takes 12 months. Build is the longest step in the software development process. And so activity B goes to D as well as C, again because D can't start until both B and C are completed. Next, activity E, which will come off of D, and activity E is 6 months, and activity F can also start as soon as D is complete, and that takes 8 months. And now we have activity G, which can start once both E and F are complete. And G is going to take 1 month. And last but not least, we've got command center setup and go live for the entire project. And that can't start until G is complete. So here H, getting that command center set up and everything ready for go live takes about 2 months. Okay. So now we have our completed activity on node network diagram. So now that we have all of the predecessor relationships in place, the next step is to go through and calculate all of the early start, early finish, late start, and late finish times. These are essential to understanding which activities are on the critical path and how much slack time something that's not on the critical path has without having it derail the project. So the way we do this is we start over here at activity A. This is going to be time 0. The earliest time we could start activity A is time 0. And in order to get the earliest time we could possibly finish activity A, we just take time 0 plus the most likely time to complete this activity, which is 4 months. So 0 plus 4, we put a 4 over here. Now we carry that early finish over to the activities that follow. So remember, B cannot start until A is complete, so the earliest time it could start would be at 4 months. We do 4 plus 3, and that will be 7. And again, the earliest time C could start would be 4 months when A is complete. 4 plus 6 is 10. So now we go to D. So remember, D can't start until both B and C are complete. So when we're moving forward, doing a forward pass through the AON, we're going to pull the maximum from the predecessors in this network. So, right, B is going to potentially, the earliest time it could finish would be 7 months, which would be great, but D can't start until C is done. So the earliest time we could start D would be 10 months, plus 12 will be 22. We pull that 22 over, plus 6 would be 28. We pull this 22 over to F, 22 plus 8, this will be 30. And now we can go over to activity G, and activity G is going to start at, earliest start at 30 plus 1, be 31. And then we go over here, we pull this 31 over to H, plus 2 will be 33, right? So if we're looking at the network using the critical path method, that our expected completion time for the project will be 33 months. Now to do the backward pass and understand which activities are on the critical path, we pull down this 33 here and we move our way backwards. This is called the backwards pass. So 33 minus 2 will bring the 31 over here, and as we move back, we take this late start time for the activity and we pull it backwards. So we're going to pull this 31 over, minus 1 here will be 30. And now if we've got 2 predecessors to this activity, we're just going to pull that 30 over to both of these activities. So pull a 30 here, minus 8 will be 22. Pull the 30 over here, minus 6 will be 24. Now as we move to D, since there are 2 activities that follow it, when we're looking at which one to pull over on the bottom here, we're going to take the minimum. Remember when we did the forward pass, we were always pulling the maximum value over? When we do the backwards pass, we're going to be pulling the minimum. So we're going to pull this 22 over, minus 12 will be 10. We're going to bring this 10 over, minus 6 will be 4. The 10 over here, minus 3 will be 7. And again, we're going to be pulling the minimum over the 4 back to 0. So there we have our completed activity on node network. And the way we determine the critical path, which is the longest path through the network, are all of those activities that have no slack time, which means that the top, the earliest finish time and the late finish time, if there is no difference between these, that means you have to make sure this activity is done on time in order to maintain or keep on time with your project. So in this case, those activities that have no slack are A, C, D, F, G, and H. This is your critical path. These activities up here, B and E, they actually have a little slack. So for activity B, because it's being done at the same time as C and it doesn't take quite as long, we have some wiggle room here. So you could potentially, if you needed to adjust resources, you could end up starting, the late start time here is month 7. You could end up starting this at month 7 and still be okay and keep the project on track. If you have any questions as you work through this example, please let me know. Again, the solved example will be available in Module 3.